Okay, so what was the next one? 27? Okay, so 27 says find the value of t that produces the given, produces the graph in the given quadrant, quadrant 1. Okay, so here's what we have. Let me just sketch this real quick. For problem number 27, we have a parametric equation. X is equal to 4 minus the absolute value of t. Y is equal to t minus 3. And the graph that we see on the screen, t is bound between -6 and +6. And the boundaries are inclusive, right? So what they're looking for is quadrant 1, and so they just want this little section of the line. That's all they want. Now we could do this on a calculator through guess and check, but what's another way we could do this? Well, what's the point right here?
0, 1.
0, comma 1. Okay, well this is easy enough to find. I could say that x is equal to 4 minus the absolute value of t, but what could I write down for x? 0. Right? Mm-hmm. If I move 4 to the other side, I got negative absolute value of t is equal to -4, divide both sides by -1, and I get the absolute value of t should equal 4. Well, technically when I remove that absolute value sign, t could be positive 4 or -4, right? Yes. Well, I can determine that rather quickly. So what Mr. Adams is really trying to do is figure out what t is for the point 0, 1. Well, I can determine that quickly if I start off with the y parametric equation, and I'm looking for when y equals 1. By adding 3 to both sides, I get t is equal to 4. So here, t is equal to 4. Now I just need to find this point here, which is 1, 0. So similarly, I'm going to say, instead of, I'm going to say 1 is equal to 4 minus the absolute value of t. Why did I plug in a 1 there? Because that's my x value. Remember, we're trying to figure out what t is here. Well, if I move the 4 to the other side by subtracting it from both sides, I get -3 is equal to negative absolute value of t. Dividing both sides by negative means the absolute value of t equals 3. So now t could be positive or -3, right? I'll just slide that up there. So I'm going to go to my y equation, and I'm going to say 0 is equal to t minus 3, or 3 is equal to t. So we're going to say that t is equal to 3. So my boundaries for t should be 3 to 4. Now how could I verify that before I plug it in? Well, I mean, I could check and see if it's one of the multiple choice answers, and it is, but let's assume that this is a constructed response question on the ACT. How would I do that? Well, I could graph it. So what I could do is I could come in here, change my mode to parametric equations, and graph it, and I've got x is 4 minus second catalog absolute value of t, and y is equal to t minus 3. And then I'm going to come over here to my window set and let my t minimum be 3 and my t maximum be 4. We only need the first quadrant, which is 0 to some positive value, I'll say like 2. And then for my y, in the first quadrant, I just need 0 to some positive value, we'll say 2. So I'm really just going to graph this quadrant here. Okay. So now let's hit graph, see what we get. Yep. I suppose I could zoom out and make sure it doesn't extend beyond that, right? So if I hit standard zoom, and then I want to go back in and double check and make sure, see when I hit standard zoom it kind of changes, so I'm going to go from 3 to 4. Now hit graph. Yep, just that little corner. Any questions?